Hello students, welcome back to Info Tamil's Maths program. In my last class, I have started a new topic for A-level second year. The topic was normal distribution. Under the normal distribution heading, I have actually went through three subheadings. One is the normal distribution itself, and the second one is the inverse normal distribution, and the third one, which I have covered last week or last class, in my last class, is the standard normal distribution. All three subheadings are coming under normal distribution. So normal distribution itself, inverse normal distribution, and standard normal distribution. Now I'm going to go through the normal approximate normal distribution, approximation, to binomial distribution. Binomial distribution. So this is the first one, is normal distribution part 1. We did it last time, part 1. And part 2, part 3, this is going to be part 4. Prior to start normal distribution approximation to binomial distribution, I would like to go through all three topics, just a recap of what we have done last week or in my last class. Let me start with normal distribution. As I have said before, the normal distribution, there are three properties come to your mind straight away. It's a bell-shaped graph or bell-shaped distribution, and symmetrical about mu, and then again area under the curve is 1, or probability under the curve is 1. These are the three properties regardless of going through the questions or going through the data has been given, just normal distribution, these are the three properties you have to keep in mind. The mu, symmetrical about mu, the bell shape, and the under the curve is the area under the curve is 1. So these are the three. In that normal distribution, and here this way is the x, the random variable. Random variable, and this is, of course, this is the frequency. So in that the first part, we actually calculated the area for particular the x value, say x equal x1, x2. So there are the area under for particular value of x. It can be it can be three type. One is the probability, which the area is a probability x less than x1, or b x greater than, say, x2, or in between, p x greater than x1 less than x2. So between these two values, the area of, or the probability, or the probability of data will accommodate between the two values, x values. Or it's another one you see what you normally get, x less than x1 or x greater than x2. What that is, it's this side, that side is when you say in statistics or, it means plus or addition. This side plus this side. So in other words, in one word they're asking this one. So what they're asking, the area less than x1, area x2, area greater than x2. That's what they're asking. So these are the three type of questions, just normal. As I said before, that's not the exam type of question, but that's what it is. So so you need to know the normal distribution, the calculating the area of the normal distribution. The next one is the inverse normal distribution. Next one is number 2 or part 2, inverse. Inverse, again, it's just the bell shape, and that's mu, and of course the standard deviation, sigma, is for normal distribution. Normal distribution normally is x equal normal, it's not x, distribute normal, the mu and standard deviation squared. This is normally, so it's how you actually distribute. This is the notation for the normal distribution curve. X normal, it stands for normal distribution, mu, standard deviation squared. This is for the normal distribution. Then inverse. What inverse? The other way around. It's the opposite to what we have actually done in normal distribution. So that in sometime they give you this area. The area is given, then find the value of x1. So you do the inverse. In that number 1 and number 2, we have to use a calculator, the normal distribution, and the option 2 for the first one. This one, option 3, to calculate the value of x. Before the normal distribution, the value of the area we calculate with the value given. Now the other way around, the area given is find the value. The third one we have studied is the standard normal distribution. Standard normal distribution. Standard normal distribution. Again, the same thing, all it is, you have to do coding. So same normal shape, the bell shape, the normal distribution, the bell shape, area under is 1, and the symmetry about the mu. But here, what it is, we use this method, standard normal distribution, in order to find mu or standard deviation. So the first one, the standard deviation, mu is given. Mu means the mean value, the population mean value, and the standard deviation given. You actually find the random value of x. The second one, inverse, you have given the area and find the random value x. The third one, you haven't given either mu or standard deviation. It gives you as different values in order to find the mu and standard deviation. In that, if you actually come across where you haven't given mu or standard deviation, mu or sigma, then you have to convert or model the normal standard deviation into standard normal deviation. What that is we have to do a coding. So what coding is, you change the value, x value, into z value. This is x value into z value or z value. Z equal x minus mu divided by standard deviation. This is the coding. So if you have a mu there, the mu, and this value is mu x. So x minus mu was standard deviation, mu minus mu was standard deviation, this is 0. So when you have a standard normal deviation, mu is equal 0 and standard deviation is 1. Say for example, if you take this mu minus sigma. So mu minus sigma, so you use this one. The z value for that is mu minus sigma minus mu over standard deviation, which is minus 1 on this one, and that side is plus 1. So standard normal distribution, the mu is 0, sigma is 1. So obviously, if you haven't been given these two values, you actually change the normal distribution into standard normal distribution in order to use 0 and 1. So these are three things we have gone through in my last class. One thing I haven't mentioned before, it isn't quite important for this particular normal distribution, but it's better to know that information. When you come to this, the middle one, we say it's mu. The mu is the population mean. At the same time, when you have a normal distribution, it's a perfect bell shape. This is a symmetry. When you come to symmetry, you actually have median and mode, same as well. So in other words, mean, median, mode are all equal. Mean, median, mode are equal. But we don't need to worry about this one. We are not going to use these two properties for our calculations here. So we don't need to know about it, but we just, it's an information for you to know, is the mean, population median, population mode are equal when it comes to normal distribution, right? We have actually gone through three topics or three subtopics. One is a normal distribution itself, the inverse normal distribution, standard normal distribution. So the normal distribution, you find the area with given x value, and the inverse normal distribution, you find the x value with given the area or the probability. And the third one, you haven't been given either mu or standard sigma. So you know, if you come to that situation, you have to change the normal distribution, or you have to modify the normal distribution into the standard normal distribution. All you have to do, you have to use this coding, z equal x minus mu over standard deviation or sigma. So these are the three we actually covered last week. I just run through it for you to sort of follow the next topic and then refresh your memory. Right, the fourth one, part 4 or fourth one, as I said, the normal distribution approximation to binomial distribution. I will call this part 4. So normal distribution approximation to binomial distribution. So the approximation itself, the word itself, it's telling you it's approximation. It's not the exact conversion from normal distribution to binomial distribution to normal distribution. So binomial distribution, then we convert that binomial distribution into normal distribution. It's an approximate approach. It's not the exact conversion. Before go to this one, I need to go through what is binomial distribution. So binomial distribution before I go to binomial distribution, what is binomial? Binomial, bi, it means two outcomes. So binomial is bi means two outcomes. So any two outcomes. Say for example, toss a coin, there are two outcomes, head or tail. And you can ask a question, can you only use it for toss a coin, only the two outcomes? But no, you can actually use it for any number of outcomes, but we need to modify that outcome into two outcomes. Say for example, dice. A die. Yeah, dice. So six-sided dice. Six-sided dice. It has six sides. So 1, 2, 3, 4, 5, 6. Of course, there are six outcomes. Can we actually use binomial? If it's a six outcome, we can't use it. But we can use it for a particular outcome, which is, say, for example, you want 4. So you actually modified 4 or not 4, or 5 or not 5. So even though 6 outcomes normally, we can actually modify that into 2 outcomes. So this or not that, success or not success, pass or fail, that sort of thing. So here, for this one, 6 outcome, 4 or not 4. Now, there are 2 outcomes, is 4 or not 4, 2 outcomes. Therefore, I can actually use binomial distribution. So binomial distribution is 2 outcomes, right? At the same time, there's a basic difference between normal distribution and binomial distribution is the data type. We mentioned before the numerical values or numerical data. The basic difference between the normal distribution and the binomial distribution, the 2 types of data. One is the continuous data as data, and second one, discrete data. Discrete data. So this is actually explained to you before in my first class when I start doing the normal distribution. Continuous is the decimal values. It can take any values, but discrete takes the whole number as 1, 2, 3, 4, minus 1, 5. 5, 25, whatever. So discrete value, continuous value. So what we are doing, when you're actually approximating, when you are changing the binomial distribution into the normal distribution, we need to think about the discrete data change into continuous data. That's the basic difference between the two. So you are changing the discrete data into continuous data. How you do it? Say if I have a value, say data, say this one, the discrete data, x equal 5. What we need to do, we are actually changing this 5 into a continuous data. When you do that, what you have to do left-hand side and the right-hand side to take the approximation. Left-hand side, what is 4.5, right-hand side 5.5. So the x equal 5 is the discrete data now become 4.5 to 5.5 is a continuous data. So I change the x into the continuous data, x equal 5 into continuous data, which is 4.5 to 5.5. So this is how you approximate that. So when you actually have a normal binomial distribution, you have the values, x equal 1, 2, 3, 4, whatever. Then when you change that into a normal distribution, you need to think about this, the either side of it, the middle number. So if it's, say for example, this one, this side, x equal 4, that side, x equal 6. So we need to, so these are the discrete numbers. So when we do the binomial distribution, the discrete numbers 4, 5, 6. But when we change or convert that, we need to look at the middle number. Between 4 and 5 is 4.5. Between 5 and 6 is 5.5. So now 4.5 to 5.5 is the continuous data. If there's somebody asks, well, let me go into the distribution, binomial distribution. Right, yeah, so it's just binomial distribution, 2 outcomes, and another binomial distribution, another property is each time is a fixed amount of trials we have to do. Say, for example, you toss a coin, if you want to test it 50 times, you do the same again. You do the same again. So you just do many trials. So it's just 50 trials, do that, toss a coin, how many heads and how many tails, or how many heads. And then toss a coin again 50 times, how many heads. And then you actually collect the data and distribute onto binomial distribution. Then again, when you toss a coin, head or tail, there's 2 values, pass or fail, or head or tail. So you have to have numbers, whole numbers, sort of 5 heads or 7 heads or 25 heads, whatever. So it come up as the discrete value. So if I could put it as, and then again, this is the many sample as possible, the many trial as possible, not sample size maybe 25 or 30, but many trials, sort of 100 trials, many trials are possible to get the distribution symmetrical as possible. Symmetrical as possible. So this is the values, the discrete values, whatever values, 1, 2, 3, 4, 5. So trials, so how many trials is about 1 to 5? 6 trials is 1 to 5 or 0 to 5 outcome. So trials is, say, 20 trials every time. So each time 20 trials, how many heads or how many fours? If you are looking at the dice, 4, not 4. How many fours? Next time, how many fours? How many fours? You come across this one. So this is the binomial distribution. These are the discrete value. This value, x value, are discrete value. These numbers are whole numbers. This is, as I said, is 1 or 0, 1, 2, 3, 4. Yep. So 5 trials. 5, the number of trials or the sample size. But what we are doing, this particular topic or particular section we mentioned, we are approximating the binomial distribution into normal distribution. So the normal distribution is a kind of like that. So it's the binomial distribution, and then we are changing into or approximating into a normal distribution. The binomial distribution now, that's for the particular, why you can ask the question, why you change it. That's for the calculation purpose. They want to change the binomial distribution into normal distribution. We don't want to go into that now. What we want to go into is the binomial distribution into normal distribution. So the binomial distribution numbers, 1, 2, 3, 4, 5, whatever. And then we actually draw that normal distribution. Again, that is the value, mu, we want to, and standard deviation. If it's a normal, so there are 2 things. One, so I could do that. This envelope, you can x distribute, normal distribution, mu, and standard deviation squared. Standard deviation squared. And if it's just the binomial distribution, that value, or this one, will be, again, we can write it as, we can't actually write x because that is the normal distribution. We use the notation for normal distribution x. So this should be something different, y distribute b, and then mu N and P. And you can ask the question, what are these? So this is the actual, how to actually distribute. This is the notation for the binomial distribution. There's a normal distribution. B for binomial, N is a sample size, P is the probability of a particular activity happening. I'll come into that in a minute. And this one, X is the random variable for the normal distribution. This is the Y is the random variable for binomial distribution. So now we are changing binomial distribution, the normal distribution. Here is normal, mu, squared, sigma squared. When you actually approximate, or when you actually change from a binomial distribution into the normal distribution, there is an equation we use. So now this is what we have, and then from that we have to get this. So there should be a relationship between N and P, mu and sigma. So what that is, mu equal NP. The sample size time the probability of whatever the activity happening, or as I said, I'll come into that in a minute. And then what is the next one? Standard deviation. What that is, the square root of NP 1 minus P. These are the two. So the binomial distribution, this discrete variables or random variables, how we can notate or how we can represent is Y, the value or random value of binomial random value, is B is binomial, N is the sample size, P is the probability. You change that into, if it's, as I said, this data as possible as good as to convert it to the normal distribution. If the data is different, but then the approximation would be really bad. I'll come into that in a minute. So you convert that. X is the normal distribution random variable. X distribute N that. So as I said, when you actually convert, there is a relationship. There should be a relationship to convert this into that. What that is, mu is N times P. Sigma, which is standard deviation, is square root of NP 1 minus P. Then, as I mentioned, this data, the binomial distribution data, it should be as good as the normal distribution. It also bring up a bell shape. How that you judge that? If the n is greater than 50, and the p as close as 0.5, it's 50. So this is a rule of thumb. This is rule of thumb. Just the bigger the better. Bigger the number, bigger the sample number is the better. So anything more than 50, and the probability closer to, not it has to be exactly 0.5. It's closer. Say it could be 0.4 to 0.6 or something like that. So as close as possible. If it isn't, then the approximation is getting worse. So approximation may not be as good as the actual real value. So n should be greater than 50, p should be 0.5, roughly between 0.4 to 0.6. That's a probability. Once you got that, say if you know the n, then n times p gives you the mu, that population mean, and then sigma will be calculated by square root of n times p, 1 minus p. What is 1 minus p? If you have that, and again, this under the area under the curve, or this 1, of course. Say, for example, if this is this side is p, that side is, that side is 1 minus p, because of the whole thing is 1. So if that is p, that's other side is p. Sometimes they call 1 minus p as q. Some questions, they probably say q. Q means 1 minus p. So regardless of going into the detail of what is q is 1 minus p. If you know p, that's 1 minus p is q. These are the two approximations. So binomial distribution, you approximate into the normal distribution in order to do some easier calculations. So this is what you have to do. Let me do some questions. Oh, just an example. This is, say, x. Say this is the binomial. X distribute binomial NP, and the normal distribute, say, y. B normal. Mu standard deviation squared. Say, for example, this is 5. If they give you, find the probability, this x less than 5. If they ask you to find the probability of x less than 5. So x less than 5, of course, this side of it, whatever from 5 to all the way to either 0 or even the low value, whichever the low value is. So it's 5. This is no, when they say, if there's this one, as I said, this is the discrete value. X is a discrete value. When you say 5, less than 5, then what they mean by is the next value and below. So this is equal in the normal distribution, or in reality, what this one is, the less than, the next less value from less than 5 is 4, 3, 2, 1. So probability of this one is probability of x equal 4 plus probability of x equal 3 plus probability of x equal 2 plus probability of x equal 1. So this is what this one is, the cumulative data. So it's just x less than 1. That means this is a discrete value. Anything less than, so the next smaller value than 5 is a discrete value. Smaller discrete value than 5 must be 4, and then less. So x equal 4, 3, 2, 1. You can calculate that by using the binomial equation, but there's a way to, well, this calculator will give you to calculate that. Yeah, if you could do that. So, for example, the next one I'm going to say x less than equal 5. If they ask you to find that, less than equal 5, what they mean by that, they say that x equal 5 and less. So 5, 4, 3, 2, 1. So one more. So this will be probability of x equal 5 plus and so on, probability of x equal 1. So this is what it is. So if they say greater, the same thing. Greater, the same thing. Now, we're going to sort of convert this, as I said, we're going to convert this into a normal distribution. Before I mention it, when you have a discrete number, when you convert that into, you have to see either side of it. Say if it's 5, it's 4.5 and 5.5. See, let's see this one. I'll come into the calculation in a minute, how to calculate, how to use the calculator to calculate this. But I just wanted to go through the approximation first, how to calculate when you actually change that into normal distribution, how to calculate. Let me go through that. Right. So x greater than 5. Say x greater than 5. as I explained to you before, x is the discrete value. Now, with the anything greater than 5 must be 6 and so on up to whatever the value is. How you can do that into normal distribution, as I said, if this is 5. So the other side, the right hand side of the 5, the next number, this one, what this one says, it starts from 6, 7, 8, 9. If it's n is 10, up to 9. Up to 9. So 6, 7, 8, 9, the probability, the cumulative probability. But if we change into normal distribution, how do you do it? So we need to find the next number, which is, say, this is 6. But this side, this is if it's the binomial, we need to start from 6. But if it's a normal, how you do it, that is for y. So probability of y, it has to start from the middle. This one is 5.5. So if it's a binomial, we have to start from 6 onwards, the right-hand side. But if it's the normal, when you actually approximate a normal, we have to start this side of it. So 5.5x greater than 5.5. X greater than. This is the normal distribution. That is, y. There's a normal distribution. This is the discrete binomial distribution. So binomial distribution, the discrete value, x is a discrete value, y is the continuous value. When you have the continuous value, we have to approximate this side of it. But you can ask the question, this is greater than 5. Shouldn't it be 4.5? No. The next value, because of greater than that, next value will be 6. So the left-hand side of the 6 is 5.5. Say, for example, p, x greater than equal 5. Greater than equal. That's now the discrete value 5 and above, 5 and more. So 5, 6, 7, 8, 9. But when you actually approximate p, y greater this side of the 5, that is 4.5. 4.5. So there's just two major difference. The greater or equal. Then this is, just a normal distribution, just greater. When you have greater, then the next number, 6, we have to start from 5.5. When you say greater than equal, greater or equal, then the 5 includes that. So you need to come, the left-hand side of the 5 is 4.5. So y greater than 4.5. There's a hell of a difference. 5, x is greater than 5, x is greater than or equal 5 is different in calculation when you come to normal distribution. Let me do that again for the calculation purpose. This one is x distribute binomial distribution n p, and this normal distribution we approximate to normal, so from a binomial to normal, and then again the random value change is not x. So y equal, or not equal, distribute normal distribution mu standard deviation squared. And if they ask you number 5, x greater than 5, and as I said, you can calculate that with a calculator for the binomial distribution, but we are doing this normal distribution, the conversion to normal distribution, from binomial distribution to normal distribution. When we do that, as I said before, that is equal p y greater than 5.5. So 5.5. And if we could, in order to calculate that, we need to use this conversion. So mu equal NP, and standard deviation is square root of NP1 minus P. I need to get an example in order to calculate better. So let me just sort of run through it again. Let us have a quick break, and I'll come up with some questions to explain that. So as I said, we started with the normal distribution. There are normal distribution, inverse normal distribution, and the third one is the standard normal distribution. The fourth one is the conversion from binomial distribution to normal distribution. This is how I did the binomial distribution. The major difference between the binomial distribution and the normal distribution, the data, the type of data. It is the discrete data, the continuous data. And then you change that the discrete data into continuous data. This is what it is. So you just to adjust that both sides of it. So if it's 4.5 and 5.5. If it's 6, it's 5.5 and 6.5. And then you have to study that well, because if that x is the discrete data, when you say x greater than 5, the higher discrete data will be 6. So when you actually approximate that, you have to go left-hand side of 6, which is 5.5. As I said, let us have a very small break, and then come back to you with some calculations. Thank you.